Hello all, welcome back to my YouTube channel. So guys, in today's video we'll be discussing about the project which we'll be creating it using Dask, the library about which I have discussed you all in detail in my previous video itself, where I have explained you all in detail what is Dask and how you can do parallel computing using Dask, and I have even compared Dask with PySpark also. You can have a look on that particular video. That video link will be in this video description, where I have explained you all in detail about Dask completely. So if you see that, you will get the idea how you can use Dask, and in this video we will be doing the project related to that. So now let's not waste our time. Let's dive into our computer screen and discuss more about that. Before that, if you have not subscribed the channel, do subscribe the channel and on the bell notification. So now let's get started. So guys, for this particular project, I'll be having my frame at the hub here so that you don't get any interruption when I'm writing the code or something. You don't miss it. So I have already created a folder here named as Dask project. So you can create a folder and open that particular folder. So this is the dataset which we'll be using, flight larger. It's nothing but I'll be explaining you all the use case further. First, let us configure it. Then we'll discuss about the use case. I'll give a left click and click on show more. Here I'll open it with my VS Code. You can even open it with VS Code, but this will be easy method for me. So I normally use this. So here what I'll do, I'll go to this terminal and click on new terminal. And from here I'll be using git bash. So I like to use git bash more compared to command prompt or even or PowerShell. So it will be easy for me. So I'll be using Git for this particular configurations. So here what I'll do will be creating a VENV. VENV is nothing but virtual environment. Why we are mainly creating the virtual environment? Because see, the configurations will be varying from one project to other project. So accordingly, if we create a VENV and if we install everything whatever we require separately, so that there will be no interruption. If you don't create any VENV from one project to other project, the requirements what we have installed, in a sense libraries, it will be varying, right? The versions might vary, and even the library might only not require for another project to run. So in that cases, what happens after some days, if you again come and run this particular project, it will not run because some file or else some version might be changed or there is some interruption or error. So because of that, there is an issue. But when we create a VNV, it will be having the proper versions and even it can maintain the proper resources and everything. So there is no chance of any project interruption or anything when you run later. So guys, let me just create VNV. For that, you should have a Anaconda installed. I have already installed Anaconda, so it's showing a base you can see here. Or else you can directly type Conda activate base, so it will activate the base. Now here what we'll be doing, Conda create -v, and here we'll be giving as our V and we name as Dask project. Python version is not required now, so let's create it. Okay, -h -n. Okay. Or else you can give your -p. Okay, it's creating. So it's asking whether to install everything or not. So let's give yes and enter. So it's creating everything. So it's done. Now what we'll do, Conda activate. So Dask project, enter. So now that particular project is activated. Now here what we'll be doing, so I'll be just launching my Jupyter notebook or else Jupyter lab. You can take anything. So I'll just launch Jupyter lab for this. It will be better to work. It's taking time to launch. So guys, let me explain the use case for you all. So in this particular project, what we'll be doing is we'll be predicting the flight delay prediction, how much time it's going to take and what is the delay, why is it going to take delay and everything. We'll be discussing more in detail. So this project is mainly used to predict the parallel computing. Using parallel computing, we'll be doing this. So guys, what we'll be doing and what is the use case, everything I have explained you all, and don't worry if you are not understanding that also. When we are implementing step by step, whatever code I'll be doing, I'll be explaining you all. At that time you will be getting it in detail that what I'm telling you and what we'll be doing with this data set. So now let's start implementing the project. And in between, if you have any queries, you can comment below. I'll answer them. So let's start implementing them and you will get to know like what exactly we are trying to do here. So first, the step one will be to install the required libraries. So let me just write it here. Install the required libraries. So this is connected with link actually. So let's enable this first. So you can see here in link. So install the required libraries. I'll tell you what is this actually and what I'm trying to do. First, let us execute the code. Then you will get to know. So first I have to install pip install Dask complete. There is a library called Dask complete. This should be installed. Pip install Dask. Pip install Dask. So data frame, and we have something called as, yeah, these libraries are enough for now. Yeah, I forgot. Pip install Dask ML. There is some pip install Dask ML. So let's execute this. Now this is getting executed. You all can see here. So why I have typed here install the required libraries, because that cell is running right now. But whatever we'll be typing, whatever the steps will be there, everything will be created here in the form of a flowchart. Don't worry, I'll show you all when it comes to the next steps. So let these all libraries to get installed and let the cell to run completely. Then I'll tell you what is the use of this. By that time, you all might think from where I am getting all these library names and from where I am installing and everything. So these are nothing but if you see the Dask documentation, you will get it easily. So Dask documentation, let us search for Dask documentation. Yeah, this is the website dask.org. So in this, if you can see here, when you check for docs, if you click on docs, you'll get this particular website. I guess you did not see like from where I was clicking. Let me just go back. Yeah, let me just open it properly, because if you see my frame, whatever you are seeing me right at there, this docs thing is covered. Let me just push it a bit down so that I can show you better. Yeah. So if you see here in this docs, if you just click on this docs, so if you click on this docs, it will take you directly to the Dask documentation. Now let me take myself back up and let's continue it. I'll try to make myself a bit small so that it will be easy. Yeah, let's keep it here. Okay, let me lock it. Okay, so now let's continue. So if you can see a Dask, Dask is a flexible library for parallel computing in Python. Even the Dask community is strong and it is mainly used for parallel computing. If you can see, the main two components why we are using it is for dynamic task scheduling and even big data collection. So when it comes to the Dask, it is an alternative to PySpark, you can say, which the data engineers will be using, right, in their big data collections and loading their data and everything. So Dask is similar and it's alternative to PySpark, but I don't know why, but Dask is a, like, you can say that it's a underrated library. But if you can search on Dask and if you try to study about Dask, right, Dask is very interesting. You will feel it very interesting and even you will feel it like challenging to solve the use cases using Dask. So only I'm making this particular project using Dask. So let's implement it till end. Before this, I have even created a video, a complete tutorials on Dask, like how to execute Dask, how to whatever things they have explained here in this documentation, how to execute the code and everything. I have explained in that particular video in detail. If you can see here at the up, you will be getting a link of that particular tutorial. You can have a look on that and do subscribe the channel and also do like that particular video. So now let's continue implementing this particular project. So this is done. Installation is done, right? Now let's continue further. Let's import the required libraries now. Let me make it here a note. Install the required libraries. So we have given here install the required libraries. Okay, so let's make it a note here. This will be first, and this here we'll be giving it as importing the required libraries. So let's check it once and let's see if possible. Let's select it out. Yeah, importing the required libraries. So now let's make a note on this in detail. So whatever libraries we require is import OS. First we require import OS because we'll be using Dask UI and it is like a bit very crazy. If you can see the Dask UI, don't worry, I'll run it and I'll show you all. Import JSON. Import math library. And now we will be importing Dask. And let us import NumPy. I already installed NumPy, so I don't require it to install it here. If you have not installed, then do install it at here itself. Pip install NumPy, just type for it, it will get installed. So after this, what else is there? Yeah, import Dask dot multiprocessing, and we are left out with import dot distributed. Okay, let's change it. It's not import, it's from dask.distributed import client, capital C. So let's run this. It's getting imported. Let's wait for it to get imported. So let it get imported. By that time, if you can see here in this Dask documentation, Dask array, Dask data frame, everything, it's like, if you can see the documentation, it's very good. I recommend everyone, whatever you are learning, whether it's Python or else Dask, or even it might be SQL or anything, even machine learning. When it comes to machine learning, there is a great documentation and the example codes also are very interesting and easy to use. You can see here how can you use the particular code in Dask. They have explained in detail. So import Dask data frame as DD, pandas as PD. So they have made a small comparison with pandas and Dask data frame, how to load the data, everything will be seeing, but it is like a bit interesting. If you read this documentation, I would recommend you all to have a look on the documentation. I'll be providing the link of this particular documentation below this video description. If you want, you can have a look on that. So yeah, importing is done. So now let's start with Okay, so we forgot to import Dask data frame as DD. So this Dask data frame is nothing but it is helpful for us to load the data. It is almost, you can think, in pandas we use PD, right, to load the data. Pandas has PD. So here we'll be using Dask data frame to load the data. So we will be importing this also. And let's run this first. And now let's check. So is there any directories available? Let us have a look on the list of directories and we'll continue further. Okay, so you can see here only these are available. So our project and everything is available. Even you can see here we have created our we have our data set available here. So we'll be using this flight larger.cv data set only. So we'll continue with this. Before that, like, we have to call Dask. So let us call Dask. Before, we have to import the client and we have to make the Dask UI up to run for parallel computing. So we are enabling the client parallel computing. And to this. Okay, so 30 words are done. So let's just mention it as compute. So this one we will be using after importing the required libraries. We have to enable this. So this is selected. Now done. If you can have a look here, so you can see here whatever we are doing. Okay, so this is not with that. Okay. After importing required libraries, we need it. Yeah. We can see here. Okay, so now let's continue here. Let's import the client first. Client is equals to, so how many clients we want? So we already imported the client here, right? So from Dask distributed, we have imported the client. So we'll be using this client only. The small c and client which is there, right? It's our variable. And inside that we are writing client. So in this client, we want number of workers is equals to, I'll be assigning 3 number of workers. So I want the parallel computing of 3 different hard disks, or you can say like 3 different disks to get computed. And threads. Threads per worker is equals to 1. Only 1 is enough. But I recommend you all, I have already explained about this client, how to import and everything in detail. You can have a look on my previous video, the complete tutorial. So I'll be not explaining about this in detail. I'll be just giving the overview only in this, because the main focus of this video is for projects, not to explain in detail about the concepts. Process is equals to, let's enable it as false and let's run this. It's taking time to run. By that time, let's check even client also. Once it's done, let us run this. Okay, so it's done. Let me just disable something. I guess it's taking more. Let me quit Discord. Steam, let me exit Steam. So that the process will be fast. I guess it's taking more time. It's not required. Let's close the themes also. Okay, so now let's check client. Client is not defined. Client name is not defined. No, we have defined it here, right? Why is it showing not defined? client is equals to, we have defined here client is equals to client. Let's rerun this again. It's showing warning. Okay, so the port is already in existence, right? So it is showing that it's using different port. Why is it showing client is not defined? Okay, wait, let's even give the port also. Port double is equals to 5000. Let's run this now. Okay. Work failed to start. CL should be enabled. Why is it not enabling the CL? I'm not getting. Run this also. Because there is some issue with this notebook only, but it should run. Let's do one thing. Instead of using this Jupyter Lab, right, let us use Jupyter Notebook and try it out with this. So let me just configure that and continue from here. Okay, so guys, I have run the same code. I have not even changed the code also. I have run the same code in my Jupyter Notebook. I guess there was some small technical issue with the Jupyter Lab. So while starting itself, you can start using with Jupyter Notebook. Just type for Jupyter Notebook and run in your command prompt instead of Jupyter Lab or else in terminal, then it will work. So you can see here, if I now run this CL, you can see here. So it has enabled the clusters and everything. Number of workers 3, thread per worker is also 1. So now let us check it in our dashboard. This is Dask UI dashboard, which I told you all. You can see here process 1, process 2 and process 3. So 3 workers we have requested, right? So these are the 3 workers which we will be using. If you want in detail, if you can click on status, this is the status. So if you click on info, you can see here these are the 3 workers which are assigned to for us. Per each worker 2.5 GB is available, 2.5, 2.5 and 2.5. So this particular workers will be executing parallelly whatever process we'll be doing. So let me continue with that and I'll show you all in detail. So this is cluster info, you can see here. Cluster info, this is process 1 and scheduler info you can see here, and number of workers, worker 1, worker 2, worker 3. You can even try to see about each worker in detail, but it's not showing that. But you can see a number of threads and number of workers, everything in detail you can read here, and even you can have a look on it at our UI. So now let's start importing the data. So the workers and the client part is clear, I guess. That was just a technical glitch in Jupyter Lab. I have to check about that, I guess. My Jupyter Lab is also running very slow. So now the concept is to load the data. So for that, what we'll be using, data frame is equals to, for this dd we'll be using. We are not using pandas here, right? So we are using dd. We have imported the data frame, right? Dask data frame, so as dd. So dd dot read. If you press on tab, you can see a read underscore csv, and inside this now we will be showing flight. I guess it should take flight class dot csv, and we are even giving it that assume missing is true. Assume missing is true, because there might be some missing values. If you don't give it assume missing is true, then it can directly run it and it will not show you the output, because if there is one missing value also, the data will not load properly in Dask. In pandas it will show you now null values, but it is not going to show here like that. So when you can see here, it loaded so fast, you can have a look on it. Df dot head, and I'll give 5. You can see here, if you directly try to see df, it will not work. Like how we used to check in our pandas, it is not going to work. Here you have to give df dot head or df dot compute. I'll even show you that also. Here you can see like what are the columns we have. mon. I'll explain you all about these columns also in detail. DOM and DOW and carrier, flight, and the organization, miles, how many miles it's done, departure, duration, and delay, how much delay it is. You can see here it has even taken nan here also. So now let us check how much this particular data is present. Then I'll explain you all about that in detail. So let's first check with dask.compute. Dataframe.compute. So if you check this, you can see here we have 2,75,000 rows and 10 columns. So this is a huge data set, and I have taken reference of this particular data set from Kaggle only. I'll be showing that reference link also. So this data set is executed in Kaggle using PySpark, but we'll be using here with Dask to execute. I'll show you the link. Just give me a second. Let me search for it. So guys, this is the particular data set which I have taken. You can see here ML with PySpark predicting flight delays. So this is the particular data set which is available here. In this, the data set is available. If you can have a look on that, you can see here, this is the code executed in PySpark. So this code has been executed by Rishi D. So I'll just read you all about that particular data things what we'll be using, or else let me copy it from here and let us paste there itself, so that when you're using the notebook you don't get anything difference. I'll be providing this particular link also in the video description. If you want, you can use this data set and work on this data set. So let's go back to our notebook. So let me just there itself, let me create a new node, this one. Let's give it as markdown. I'll paste it here. Let me run this. So you can see here in this, it is explained in detail like what we are using. MON, month. So month is nothing but this, MON is nothing but month. At what month we are booking the flight. And date. Okay, let me run this. Day in essence, day of the month, at which date we are. And the day of the week, in week. So it's explained in detail about that, what it's going on. And you can see here org, organization is nothing but origin airport. Org is nothing but origin airport. Mile is nothing but the distance. Carrier, it's a carrier or else ITA code. And depart is nothing but departure timing. And expected duration, so it's even given expected duration. Then delay, how much delay it's taken, and it's given in minutes, because flight is not going to take that much delay. 5 minutes, 10 minutes max, in between 1 hour. So there are some missing values also in this particular data. First we'll perform the cleaning operation, and let's continue further. So our compute is done. So this is our data set. Now let us even check the data types. df dot, and let's continue further. You can see a data types is float, 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 object, float, float. So maximum it's of floating point, even there is no integer also. So we'll be working with this. First, let us clear out the null values. Df dot is null dot. So if we run this, will it give us error or not? You can see here it's not showing in detail, because in Dask if you directly run df it's not going to show, right? So it is not going to show like that. You have to even give dot compute. Now if you run it will show you. You can see here. So only when it comes to delay there is nearly 16,711 columns null values. So that much columns or else that many flights related delay data is missing. So for this what we can do, out of 2,50,000, out of this we can 16,711. So let us just, you can see here if you just perform the multiplication, you can see here 23 lakhs, still there is nearly 23 lakhs 32,000. That's all right, it's 2,50,000 only, right? Yeah, sorry, 2,75,000. So from 2,75,000, it's not going to make that impact. So it is not even like almost 5% of the data is missing. You can think, you can assume that only 5% of the data is missing. Another 95% data is accurate, right? So it's available, right? So we can use that. So if you run it, you can see here. Now what we'll be doing, we'll be dropping this particular 5%, because if we drop this also, it's not going to take that impact. See, understand, always dropping the data is not going to work. Sometimes, like if the data is, for example, of 1 lakh, and if the null values are only of 50,000 in some column, then we have to think of treating it like using some statistical methods by replacing with the mean or median or something. But when it comes to like this, very less data is going to, like approximately 5% or 10% from the 100% of the data, it's not going to give that much impact, because if you try to replace this also, there might be chance that the accuracy can come down. So at this point of time you can remove, I mean you can just drop that null values. So now let's drop the null values. For that we'll be writing the code. So df is equals to df, yeah, df dot drop. Now drop null values. So let's run this. So you can see here this is executed. If you can see in the workers also, here also you can see in the status, if you click on the status, you can see the UI, you can see there is some effect running on here. So we have loaded the CSV and everything. You can see the changes in this workers work and everything. You can see in detail. So let's continue further. You will be seeing here, you can see. Let's continue further. You will be seeing, I'll show you all. HTTP error. Let's rerun this again. Yeah. So it's dropped, I guess. Let's have a look on this again. You can see here the it has been dropped. That 16,000 unwarranted columns are dropped. And when it comes to our data set also, we don't require flight. Flight is nothing but it's the number of that particular flight. We are just predicting the delay, right? So we don't need the number of that. So we can even drop that also. For that, what we'll be using, df is equals to df of drop. Inside this, I want to drop flight, something called as flight, comma, access is equals to 1. So let's run this. You can see here even that's executed. If you just check for these duplicates again, you can see here this flight, you can see here, right, it is dropped. If you run this, you will get to know. So that's dropped and it's stored in our DF properly. So now let's continue further. Before that, let's check df dot compute. If I run this, now you can see the data is exactly of 25,000 change columns and rows, and 9 columns are available. So with this particular data only we'll be working now. So now let's continue. Before continuing further, we'll just make the duplicate of it so that if we make any error further also, we can use the df directly. So further we'll be working on df1. So now what will be our task is to converting the miles to kilometers. So for this what we'll do, hashtag. So if we convert this to kilometers, then we can understand it easily. And then later even we'll drop the miles also. I don't think we require that further. So for this what we'll do, df1 of inside this, there is something called in this km variable. So in this kilometers variable, I want to store, or else I want to change the calculations. df1 of, so this mile column, whatever the mile column is there with me, I want to multiply it with 1.60934. So if we run this, it will get converted to kilometers. So this MUL is nothing but multiplication operation. So let's run this. So you can see here it has been executed perfectly. So df1.compute. You can see here the kilometers column, we got it. Now we can drop the miles column. We don't require the miles column now. For this what I'll do, whatever I have used for dropping, let's take this. Let me remove this. This is not required. So df1 of drop, inside this I don't want mile dot compute. So let's run this. You can see here that's dropped, and you can see here it's executed also. It's in that it cannot be replaced now. So now let's continue further. So we have done with the multiplication of kilometers. Now what we'll be doing, we'll be creating the label column. So to say that whether there is some delay or not, for that we have to create the label, right? This is in float format. If we create the labels only, right, we can easily tell that okay, it's it can show me like it's whether delay or not. For that what I'll do, df1 of label, there is a, we'll be using the variable or column name, we'll be creating label. So inside this label what I want it to be done, df1. So inside this df1, whatever is available at delay, I want that to be, if that is greater than or equal to 15 seconds. You can take 15 seconds. You can take anything of your choice. I am just taking 15 seconds. So if it is greater than or equal to 15 seconds, then convert only that things to int. So for that what I'll use something called as type int. So let's run this. Now if you check df1.compute, you can see here it has created a label for me, whether if the flight, whatever the flight's delay, it's there, right? So if it is greater than or equal to 15 seconds, if it is above 15 seconds, or if it is 15 seconds, I want it to say that yes, it is 1, so it is delay. And if it is less than, you can see here. So here you can see it's 27, it's greater than 15 seconds, right? So it is giving me 1, means the flight is delay. 1 means the flight is delay. Let me give it in markdown here. Zero is equals to no delay. You can see here. And when you see the second one, it is giving me 0, right? Why it's giving? See, it is showing minus 19. It means the flight came 19 seconds before the expected time. So that flight is that accurate. So it's showing that no, it is not delay. Like this, we have created the label, right? So now this became a classification problem. So we'll be doing with this only further our project execution. So this will be a target column, whatever label it's there, right? So that will be a target column. So now let's continue further. So now again, let us check df1.head. And here, so this is the data of head we have. So we'll be using this, and you can see here 0, 2, 3, 4, 5. Where is 1? Because 1 is dropped. That particular one row, what was there, right? In that, the null values was there. So it dropped that particular row. So our next topic will be to inside this. Now we'll be creating something called as data, a variable. So data is equals to, I want the categorized columns to be separate. df1 dot categorize columns is equals to, inside this let me mention the names. So carrier, we have carrier is the category column, comma organ, yeah, this is also a category column, or you can say these are objects, right? So we are segregating this. If you check data dot head and run this, why it did not go? Data is equals to df1 dot categorize. So we have done it to categorize, right? Let me continue further and see. df2 is equals to dot compute. Let us check df2 now once. Okay, so df2, it's showing everything. It should not show everything, right? Okay, so from this, what I want to do, df2 is equals to df, from this particular df2, I want to take all the categorized columns. So let me create it in an array format. So it will be storing in array format. For this, what I'll do, I guess it has been not executed properly for this. So let us mention that here. It should be stored in a 2D array format. And now if we check df2.head, I guess it should work now. Yeah, it's working. So these are our category columns. Separately, we have stored this category columns and we have taken its head, right? So we'll be showing, working further in this, and I'll show you what we'll be doing further. Now what we'll be doing encoding now. So we have taken this separately, right? So now the task will be to encode this particular columns, this category columns, whatever we have, right? We have to encode that, and we have to take it again into our, we have to merge that again into our object of float columns, whichever are available. Then we'll be working further with that. We are doing encoding. I have a question for you all. Why we'll be mainly doing encoding? I want you all to write about that and types of encoding in the comment below. So now let's continue further. To do encoding, what we'll be do, from Dask _ML, we'll be importing pre-processing. Normally in machine learning, from sklearn.preprocessing, we'll be encoding, importing the encoding techniques, right? Like feature hash encoding, and ordinal encoding. There are many encoding techniques, right? So we'll be importing that. Import ordinal one hot encoding, ordinal encoding. But for this, ordinal encoding is enough for us. So we'll be using ordinal encoding in this. So let us run this. So this is done. And now what we'll be doing, encoding is equals to ordinal encoder. So let us transform it. Transform is equals to fit transform, and let us give df2. So we have taken it separately, right? So now we'll be transforming it. So the transformation is done. Now if you check data frame has no object, compute. When the compute, okay, let's take head and check once. You can see here, so it's taking, right? Let us give here 10 once. You can see here it has converted that into encoding. So now we have encoded this, right? So now what we'll be doing, we'll be merging this with our df. So for this, what I'll be doing, I'll be taking df3. df3 is equals to df1 dot merge. There is a function called merge. So we will be merging tran. What's the error? You're trying to merge the int 8 columns. If you wish to proceed, use pd.concat. So I don't want to use pd.concat, right? So why is it not taking? It's fine to merge. Why is it not taking the merging? Merge. This is tran. Okay. So let it to be int with float. Let it to merge. It should get merged, right? Why is it not getting merged? Is there any operation.concat in this? df1.concat or something. Why is it not taking? I guess it's not working with this. So what can we do with this now? Without using pandas, we have to complete this project. So why is it not taking? Mhm. Let's try again once more. Still, if it's not possible, then we'll try to check any alternative if available. df3 is equals to, okay, I guess because it was not able to do, because this particular object and carrier, if you see, these are already available in df1, I guess. So let me just check this once. So these are available, so it is not able to take because of this both. First let us drop them and let us try afterwards. So df1 is equals to df1 dot drop where is that carrier and org. Let us drop this. Once we drop this, I hope so it should definitely work. Comma access is equals to 1. So let's run this. So now if we check df1 dot compute, okay, compute. So you can see here everything are right now this only. So now let's try to merge this once and let us try. I hope this should work this time. df3 is equals to, because everything are float only in this, so it should definitely take the integer values also, because label is also integer, right? df3 is equals to df1 dot merge yeah, I hope it has worked. Okay, so this was the issue. Actually, the objects were already available, right? So when we were trying to run with that, so because of that objects, it was not able to take in. So it was asking us to use pandas. There are some limitations when it comes to Dask, but we have to try to code it. You can see here categorize blocks. So when we created the categorized blocks, it gave a different color and it's working at the background still. You can see a byte process and everything is still going on. This UI you can see here, it's drop by shallow copy. So it's dropping everything slowly and it's working in detail. So when it comes to CPU, you can see here the CPU utilization and everything, data transfers, everything you can see here. When it comes to graph, if you click on graph, you can see here. Why is this scheduler empty or it's not able to work properly? You can see here the works, like how it's working. CPU utilizations, you can see here everything, what's going on and everything. It will work better when it comes to Jupyter Notebook. In Jupyter Lab, it will work better. But why, I don't know, my Jupyter Lab is not working properly. So let's refresh this once. Okay, this is working right now. So you can see here, in this it's available already. Dask3.compute. We see here, you can see here. It's already available here. Everything is here available. So now let's continue further. So our encoding is done now. Everything are numerical values only. There is no objects. Okay. So now what we'll be doing, now we'll start with machine learning process. For that what we'll do, let's import another library, import ml dot datasets as dmd. So let's take this as an example. So inside this, what it should do for me, so let us perform the machine learning operations. Normally when it comes to our machine learning, what we used to do, we used to import linear regression, logistic regression from sklearn, right? So here we will be using Dask ML for everything. If you check the Dask documentation, so in this there is something called as Dask ML. If you click on this, you can see here for cross validation, for pre-processing, even when it comes to PyTorch, Keras, everything Dask is already available. If you see here, from sklearn.feature extraction, import feature hasher. We used to use here sklearn, right? When it comes to Dask, from sklearn.preprocessing, import one hot encoder. There are many things like which you can use. So you can see here from Dask ML.preprocessing, import categorizer, dummy encoder. scale and pipeline, everything is available here. So this is mainly useful for parallel computing. If you see this Dask shaders only, you'll get to know. It is mainly useful for parallel computing. It is executing in chunks. So this is done. Import Dask ML dot datasets is done. So now let us split it. So inside this from data df3, so I want all the columns. So whatever columns are available, and that should be in 2D format. So month, comma. Let me do one thing. Let me copy all the things available. I have already copied it and pasted at one place. So let's paste it here. You can see here. So this is done, right? For X, this is done. And when it comes to Y, we can take this here. Y is equals to our main target is to predict the delay, right? So what is the delay operations? We are predicting that, right? So we'll be using these things. So, and we are even giving the Dask to load it in the form of Dask array. For that, we are giving this. N sample is equals to this much we gave as a sample. And this is a classification project. So we are doing make classification and chunks we gave 1000. So now that's running or it's done, I guess. Yeah, it's done. Now from this, what we want from Dask ML, import Dask ML dot, there is something called as model selection. So from this as DM. So we want it to import as DM is nothing but Dask model selection. So our splitting is already done. So our main target is to take it into X train and Y train. So X train, comma, X test, comma, let's take it normal Y only. Y train, comma, Y test. So this is done, right? So inside this, what I want from this Dask management dot train test split, there is something called as train test split inside this. So from this, I want to split X and Y. So we'll give the test size as 20%. So inside test, I want only 20% and 80% should go to training. Test size is equals to 0.2. 0.2 in a sense 20%. So let's run this. So what's the error? Type error. Convert mixed input is equals to true. Test size is equals to true. Okay, where it's giving DM. Test split, so it's proper only, right? Why is it giving the error? Yeah, okay, it's executed. Sometimes it happens, it tries to give the error, but it executes. So, okay, our X was capital letter, but I gave a small x, right? So it was the error which I made. Now you can see here. Now if you just check X train and run this, you can see here X train is having from that particular from this particular 1 lakh sample size. So 80 sample size is in training. If you want, I'll show you the test also. So in X test, 20,000 sample size is 20,000 in this 80%. This is easily, you can say that 80% is in training and 20% in test. So we have even defined here in 20% only. So it has taken 20% only. You can see here how much memory it is using, what is the chunks, and what is the data type it is having. Everything is available in detail inside this. You can even check for white train and white test also. Now the next target will be to import the required libraries. It's finally nothing but we are going to train the model. For this, what I'll do, import dask dot data frame as dd is done right. Dask dot model selection as import dask ml dot model selection as dms dask model selection, and from dask ml dot linear model import logistic regression. We'll be performing logistic regression for this. Now the next target will be to store this logistic regression. So classification is equals to, this is a classification project, right? So we are using logistic regression. Logistic regression. And once this is done, let's run this first, then we'll continue further. So CLF, if we call, we'll get logistic regression. You can see here. So now what we'll be doing, now we'll be training that with CLF, and we'll be even predicting it. I mean, we'll be storing it in ypred. CLF dot fit x train and y train. So this will be our task to run the training, and after this is done, what we'll be doing, we'll be taking ypred is equals to CLF dot predict x test. Let us run this. So now it's training, I guess. It will take more time to train. You can see here the training process, what is going on. So let me just take a screenshot of this also. It will be good. So I'll save that later. But you can see here the process. Its process is going on. You can see here how beautiful the UI is. It's taking the each and everything in detail. Local update, everything, the training process, you can see here whatever work it is doing, concatenation, add value, as type, aggregations, everything you can see here. Even the memory process also you can see here, whatever the work it is taking and it's working. And even if you go to info, you can see here the RAM usage, everything, logs and exceptions also you can see there. So if you click on status, you can see here still it's going on, the work is going on. Let this training to complete. Until this training completes, we cannot interrupt it. So guys, and even I would like to announce you all, if this video reaches better, and if you all comment below by seeing this project, if you all like it, if you comment it below that you want end-to-end project, a VS Code implementation end-to-end with a like using Flask or something, if you want end-to-end, then I want you all to comment below. Then we'll be using Dask only and doing the end-to-end implementation of project. So this will create an edge in your resume that you know Dask, because many of them don't know about Dask. It's like an underrated library. Many of them have not even heard. If you tell to the interviewer also that you know Dask, he'll ask you like, what is Dask? So many even recruiters also don't know about this. But if you know this, you will be having some edge. So I would recommend you all, like, if you comment below, then I'll make a video related to this end to end. So let the training to complete. It's taking time, but there are some server issues, but it's fine. Until this completes, we cannot do anything. So it's still training is going on. Let us check accuracy. Once this is done, let us check the accuracy. If the accuracy is good, then we'll continue further with the predictions. And also, guys, I have an announcement for you all. I'm actually planning to take a live Python session or something, come live and teach you all Python related to data science and even give a data science guidance. So I'm planning of that. If you all are thinking of me to come live and answer your all questions, you can comment below that you are requesting for this. Then definitely based on the comments and everything, I'll definitely come live and let's talk in the live. Let's answer the questions and everything. Even I am excited to come live and even talk to you all about the subject and provide guidance to you all. So let this to complete. It's taking more time. Okay. Let us check the documentation by the time once. Cross validation, API references are there. You have many things here which you can learn. PCA, clustering, pre-processing using robust scaler, min-max scaler, scaling techniques are there, categorizer, dummy encoding. So these are so many things are available. If you want, you can see here even about metrics. You can check MSC metrics, accuracy score, XGBoost. Dask is actually huge, but it's a bit underrated. But definitely, I think so. It will be very good enough if you all learn about Dask at the upcoming. It will be creating a edge because now you all know, right? Recently there was a release of a language for AI. It's like Mojo, yeah, Mojo language, which was released very recently. Based on that, even I made a comparison video, right? Even there also I told you all the same. For parallel computing, we have PySpark and even we have Dask, but they are claiming that Mojo is faster compared to all this and even Python. It is both implementation of C++ and Python. They are like the developers are saying, and it is 10x faster compared to Python. They are telling about that, but we have to see, we have to have a look on that particular language, and let us see, like, if it's possible, we'll try to create a video on Mojo also playlist. It's taking actually more time to complete the implementation only. Guess the implementation is about to end, so it's taking gaps in between chunks. Based on the chunk size, it's executing. Actually, when it comes to Dask or even PySpark, they can run fast in other dataset. There is a method called Parquet format. So when it comes to the Parquet format, that particular data which is available in Parquet format, right? So that data, it can work very fast. When it comes to the CSV, it will take more time. I hope this is done, I guess, or else let me just video length, it's getting increased. Let me just stop this for a while, and once the execution is done, I'll continue from there. So guys, finally it got executed. Execution is completed. You can see here So it took so much of time to get executed because this is the big data, right? There is nearly 2 lakh plus columns, so it took so much of time to execute, but it's fine. So now our next task will be to check the accuracy. So for this, what we'll do, we'll just print the accuracy. Yeah, first let us check the accuracy. CLF dot score, and inside this let us give x test, comma x test, comma y test, and let us check the score dot compute. Let us run with dot compute, or else it will not give us the score. Okay, so it's executing. Is there anything running? Yeah, you can see here it's running here again. It's done. Okay, so the accuracy is of 57. We can improve the accuracy, but I guess why it gave 57? This is very less accuracy. 57. In another model, so I guess this is not the right form to check. Let's print this once again. Okay, so the accuracy is 57 only. It's fine, we can improve the accuracy, that's not the matter. So the main working of this particular project was to just to show you all how you can run with Dask and how you can execute the projects. We can improve the accuracy by adding synthetic data or anything, and we can work on that. Now for this, now let us even try to make some predictions also. So for this, what we'll do, we'll just save it. Before that, let us just, yeah, we'll just save it. So this is the code, import joblib. There is a library called joblib. Using joblib, we can save this particular model. So joblib dot, this is to load. Okay, so to save the model, there is something called joblib dot dump. We will be dumping that CLF model. So you can see here, joblib dot dump model one dot pickle. So model dot pickle. So it is done. Now we will be using this to use it. So ypred, you can see here, this is the ypred. So now using this all, it's done. Now let us check the ypred once. Ypred dot compute, I guess it should run. Okay, so you can see here it is showing me in true false ypred dot compute when I run. It is showing in true false format. So now our task will be to save this again into ypred. So why I gave here again ypred, because this ypred dot compute will give you the output, but it should be saved in this format. This is ypred. So if you run this, right, so this dot compute, what it will do, it will internally convert the whatever is in Dask format, right, it will convert that into pandas format. So now if you check the same ypred again, you can see here it is saving in this format. You can directly run again and again, you don't need to use compute method. So this is done. Right now what we'll be doing, our next target will be to replace this true false with 1 and 0, because we have to replace this, right? We cannot do direct prediction when it comes to the model and prediction. It cannot directly give us in true false, right? Normally we have to change this to zeros and ones. For this, what we'll do, I have a code for this. So here only let me write ypred is equals to DA. So DA dot where ypred is into 1 comma 0. Let us run this. So DA is not defined. Why DA is not defined? So we didn't load anymore. Hmm. Okay, import Dask array as DA. So now this is done. So now if you check the ypred, so this is into this format. So now if we check the ypred once again, let me run this again. You can see here now it is showing me in zeros and ones format. Okay. So now this is done. The replacing and everything is done. True, false we have replaced to zeros and ones. Now what we'll do, we'll just check the matrix MSE mean square error and then let us continue further to the prediction. I know the prediction is not going to be that good because by seeing the MSE you will get to know that and the accuracy will get to know that the model's accuracy is very low, 57 I guess. Yeah, 57.33 is the accuracy. We have to improve the model's accuracy, but you can see the MSE is also just giving me 42 point change. So it's giving me perfect MSE also. There is no interruption in between. So let us just do the basic prediction for now, but afterwards when we are going to do the end-to-end project, we'll try to improve the model. So we have loaded the model, right? Already we have used the load model to make loaded it. Then what we'll do, we'll start making the predictions. For this, what we'll do, use this load model. So ypred 1 is equals to, inside this what I'll do, clf dot predict x underscore x new. So I'll just give that as x new. And what I'll do, y1 is equals to ypred 1 dot compute. X new is not defined. So MSC is done. Okay. So if we need to make predictions, we need something like new data we have to generate. So we have not created the variable of x new. So for that, what we'll do, generating the this one. So x underscore new is equals to da dot random. There is something called as random in the task array function. So inside this dot normal size, yeah, just take it as normal, and inside this normal I'll give the size as size is equals to 10 comma x dot shape 1. So now let's run this. So this is done. Now I guess it should work. So now whatever ypred is, this y1 is there, right? Inside this we have saved this y compute, because if you check the y compute, this one, if you give it dot compute and check also, it is going to give me again in true and false format. So it made a random prediction and it gave me true and false format again. So from this x new, what is there, right? So inside this x new, we have created randomly the 10 variables. You can say 10 values, and with the shape of 1, x shape is 1. And what it happens, so when it comes to y pred 1, it has predicted with this x new, but it has given me in the form of true and false format. So this is not the correct format, right? So if you try to execute this in the output, it will not give us the prediction properly. So again, the prediction should come in zeros and ones. For that, what I did, I have stored that in y1. So when it comes to y1, you can see here it's showing in true or false format. Y1 is equals to this one. So it's again showing in true or false format. So now again our task will be to y1 is equals to d a task array dot where y1, in this y1 what it should happen, so the 1 comma 0, it should again replace with this. Now if you check y1 compute, you can see here now it's giving me the perfect this one. So 1 is true, 0 is false, again 1 is true and 0 is false. Randomly it is predicting that. So the first flight is delay and the second flight is not delay, and again it continues on. So if you see our I guess here df2 only, let us take df2, no, df3 dot compute. So if you see in this also, when it comes to the delay for the first flight, it gave us true. So there was a delay, it's above 15 seconds. The second flight, false. The third flight, true. Fourth, true. Fifth one, here it made a wrong prediction as false. In a sense, this is not the prediction of this particular data, but I am telling you all, you can take like this an example. So that is normally a synthetic data which is generated randomly. Okay, so you're getting my point. So that's all, guys. You can see here even the prediction is made and the prediction is not accurate. I know that. We'll work on that. We'll try to improve the accuracy. I would recommend you all to use this Dask documentation. Have a look on the documentation once. If you just click on this docs, you can have a look on this, and inside this you can have a research that you can make a research and you can see how you can improve the accuracy of the model and improve the accuracy. And if you have improved the accuracy, do comment below that yes, we can improve the accuracy using these methods. What methods you will be using? So use that methods and improve the accuracy, and let me know in the comment also. So guys, that's all for today's video. Do like, share and subscribe the channel. I hope that this session was interactive and this project was informative for you all.